So this is 4-3, but let's do a little review first. 4-2 was the introduction of two triangle congruence postulates. 4-1, of course, was just talking about polygons and how do we prove polygons are congruent. So 4-2 was specifically for triangles. SSS stands for side, side, side. SAS stands for side, angle, side. And that was our hint for deciding which parts we needed to prove are congruent. And as long as we can get these three congruent to some other triangles, side, side, and side, then everything else about the triangle becomes congruent. So I've shown, for example, that these three sides would be congruent to three other sides of another triangle. That means that all of the angles have to be congruent too. Or, in this case, a side and an angle and a side will match up with a side and an angle and a side from another triangle, which means that the other three things that I haven't figured out yet, those now have to be congruent. So there was an angle and a side and an angle that I didn't know anything about, but now I do. Because as long as I get this far, these three parts out of the 6 parts in a triangle, 3 sides, 3 angles, 6. Okay. As long as I get the first 3, I can guarantee the other 3 after I've shown that I've got either these 3 or those 3. So 4-3 is going to talk about these 3 sides. If we have an angle, a side, and an angle, and I have to be able to point to these in this order, and I'll show you more of that as we go along. Angle, side, angle, or angle, angle, side. These are theorems and postulates that can prove your entire triangle is congruent. This is also known as if it looks like a duck and quacks like a duck. But for geometry class, we have to add a third thing just so that we keep remembering that there are 3 parts to this. Looks like a duck, quacks like a duck, smells like a duck. So now we need our 3 ducks, and we will keep our 3 ducks in a row for the remainder of this section. So on with 4-3. First, the angle side angle postulate. This should look familiar because we may have just talked about this in class recently, huh? If 2 angles and the included side of one triangle, let's see, okay, so I need 2 angles and the included side. Ooh, that means the side that's in between the 2 angles. Okay, so angle, included side, angle. If those are congruent to 2 angles and the included side of another triangle, then the triangles are congruent. So let's name this. Let's start at B and then go to G and then go to H. Triangle B, G, H is congruent to triangle P, K, N. Second one, incidentally, this was a postulate, this is a theorem. Are you writing this down on your note cards? Here's your reminder in case you are listening to this at top speed or on mute. So, note cards, one for this, one for this. If 2 angles and a non-included side, oh, you were wondering how to talk about the sides that aren't included, weren't you? 2 angles and a non-included side of one triangle are congruent to 2 angles and the corresponding non-included side of another triangle, then the triangles are congruent. So over here, let's go alphabetical, shall we? From C to D to M, triangle CDM, congruent to triangle, well, let's see, which ones are we talking about here? We'd have to use X first because that arc mark corresponds like that. Then I continue to the next angle, which would be G. Oh, because I went from C to D, now I'm going from X to G and ending up at this point over here, T. So remember, the order of the letters matters. that tells you a lot about what should line up with what and what corresponds to what. Here's an example. If we have a angle F, just the angle, not the triangle, just the angle. Okay, so F is congruent to C, so that means, let me just highlight these. We got F congruent to C, okay, and I is not congruent to C. Now, name the triangles that are congruent using angle, side, angle. Whoa, that's really weird sounding. What does that mean? Well, we have a lot of information here. These diagrams show you some extra given information. Let's color code them, shall we? N is congruent to A and is also congruent to D. So, boy, we've got 3 triangles here, and they're telling me that we need to name the ones that are congruent by ASA. So we're looking for angle first, then a side, then an angle here. Now, we also know something about some segments. So let's mark up this whole diagram before we even really tackle this problem. F to N, so that's this side, congruent to CA. Oh, got it. And that's also congruent to GD. Ah, that's pretty. Do you see a pattern here? Do you see anything kind of that matches up with each other? Okay, so here we go, the big reveal. If F is congruent to C, oops, I should have done that in yellow. Let's redo that in yellow because that was what they told us before. F congruent to C, got it. Then F is congruent to C and would also be congruent to G. Well, where did that come from? Hold on, I got orange. So this should be a G in that box. Well, why is that? They told us F is congruent to C, but we can also figure out that that would be congruent to G because of the marks that they made. Do you see this little arc mark right here? Oh, happy. That matches this one. So we started off the day with C congruent to G, and they only told us up here that F was congruent to C. So if F is congruent to C and C is congruent to G, then F and G are also congruent. Fascinating. Now, we're saying F, N, I. Let me do this. F, N, I is congruent to CAT, CAT, and also congruent to GDO, GDO, by, oh, well, you know it's going to be ASA, don't you? But let's clear this up and let's just make sure we understand why those were all congruent. They sort of look it when we start, don't they? And look at this. We've got an angle, a side, and an angle matching up to an angle, a side, and that was the first thing they told us, C and F are congruent. So this angle, side, and this angle all match up. And that's all you need to say that every other bit of this triangle is congruent to every bit of this one over here. But wait, there's more. Don't order yet. There's a bonus. We've also got C congruent to G, so now we've got an angle, a side, and another angle that match up with one of these. Well, either one really. So they're all congruent to each other by ASA. And yes, the order of the letters matters a lot. They put F first, so that means they got to put C first in the other one, and that lines up with G. These arc marks match, so C is the starting letter on the second one. That must mean that G is the starting letter for the third triangle. Now, quick check. Using only the information in the diagram, can you conclude that let me erase this, that triangle INF is congruent to either of the other two triangles? all you have is just the stuff in the diagram, not this little bonus here that C and F were congruent. That was the only thing they described to us up here. So can we say that INF is congruent to either of the other two? Wait a minute. Let's look carefully. Oops, that's not the erase. Let's look carefully at this. I see this double arc mark here. That matches up with this arc mark and with that one. Okay, so I've got an angle. But right now I have to have an angle, a side, and an angle. Or if I knew that this was an angle, the other thing that we learned from 4-2 was SAS. And let's see, up here we had AAS, angle, side. That was a terrible A, sorry. So I know I've got an angle. I know I've got at least that much. I've got N matching up with A, matching up with D. Oh, and let's keep going. Let's follow from this angle to this side. Well, that side matches up there and there and there. Hey, goody, goody. So now, of my three options here, I've got an angle and a side that all match up everybody to the next one. Now, if I'm starting with INF, I need to know something about this angle. And I don't know anything about this angle. The diagram doesn't show me that it really matches up with C or G. If the diagram had started with that, everything would be fine. It would have been so simple. This would have been angle, side, angle, 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 side, angle, and angle, side, angle. And we would have had it. But no, we don't have enough information. About angle F just from the diagram. Now, are you saying, but I thought we just proved that they were all congruent to each other by ASA? Yes, you're right. They are all congruent by ASA as long as they give you this piece of vital information. Oops, sorry, I'm not hitting the eraser. There we go. This vital piece of information, suppose that F and C are congruent. F is congruent to C. So that's the thing that they had to start you off with in this description here. But here they take it away and just say, look at that pretty diagram and nothing else. So just from the diagram, we don't know enough about angle F to be able to say that it is congruent to either of the other two. So they want a paragraph proof here. I would like you to instead do a 2-column proof. And here's what we're looking for. Maybe in the margin on your page you can sort of squeeze this in. So we're going to do like this, statements is 1 column and reasons is the other column. These will always be the column headers in a 2-column proof. And we'll use 1 and A so that we know the statement that we're making goes with the reason over here. So here we go. We are given this stuff. A congruent to B, AP congruent to BP, AP, BP. So they've marked up the diagram for us. Great. So let me just go ahead and put those down. Angle A congruent to angle B, AP congruent to BP. Have you noticed that every time we start writing these proofs, the first thing you spit out are the givens? So why can you say this stuff? Because they gave it to you. So given, there we go. Next statement. I can't jump right to this line. This will be my last thing that I write. But there's a bunch of stuff inside here that allows me to make these leaps. Well, let's see. We're trying to use ASA. We're trying to use angle, side, angle. And look at that. I already see an angle matched up with an angle and a side matching up with another side. Now there's only one other angle that I need here before I've got the two triangles congruent. What is it? Yeah. It's right there. It's this angle congruent to this angle. Can you name those angles? Of course you can. Let's name the first one right here APX. So APX. And you and I both know that that's congruent to another angle. What's the other angle? Yep, we got to name it in the right order. We got to call it BPY. Now, that was our statement. Why can I say that those are congruent? Because they're vertical angles. How many times do we use vertical angles as a reason? Yes, a lot. Get ready. Vertical angles. That's all you need to write for me as the reason why. Vertical angles are congruent is fine, or just plain old vertical angles. So now, what do we have? We have an angle, the included side, and another angle. So if I pick up my pencil and I'm pointing to the angle, then I point to a side that was making part of that angle, then I continue along that side to the next angle. Those three things, angle, side, angle, have to match up to the other triangles, angle, side, angle. And they do. We already demonstrated that. So, last statement, the entire triangle APX is congruent to the entire triangle BPY. Now, why can I say that the entire triangle is congruent to the other triangle? Because ASA. That's all you need to write, because you have proven that there was an angle, a side, and an angle that were congruent to an angle, a side, and an angle in the other triangle. So there is the two-column version. This is the paragraph version that they were sort of hoping you would fill in. Vertical angles is what they're looking for here, and the reason was ASA. So this is the paragraph proof style. You know me, I like my columns, so that was the two-column style. Now, item 3, plan a proof that uses angle side. Ooh, well, let's see here. We have some parallel lines. Hey, it's been a little while since we saw parallel lines, but I'm so glad they're back. Now, we've got this angle congruent to this angle. Yep, given. And we are given that the lines are parallel here. Ooh. And we're trying to prove the triangles are congruent as usual. So now, what information is going to match up here? Because these two lines here are parallel, then this angle from B to A to C, so we're talking about this guy in here, is congruent to, what other angle? Well, you know what? Let me just draw it over here. I've got the two parallel lines, and then I've got a transversal coming like this, and I'm talking about this angle. So, what do you remember? What other angle could this one be congruent to? If you're saying, this guy down here, that's the exact right answer. Now, some of you might have said, well, vertical angles, Mrs. Mitchell. Yeah, you're right. You're absolutely right. That angle is congruent to this one. But that doesn't help us. We needed somebody else in this triangle. So it's this guy that we're going to talk about. So this angle will be called angle ACD. And I think I named that in the right order. BAC would be congruent to DCA. There we go. That is the correct order. I think I named it over here incorrectly when I was pointing to it. And why? Oh, because they are alternate interior angles. So now, hang on, I'll get the garbage truck out here, clean that up. So we've got an angle and an angle. And over here, here was another set of angles that we just proved are congruent because they're alternate interiors after all. So what do we have? We've got an angle, oh, and we're trying to find a side. Oh yes, do you see that this side is shared by both triangles? So it's congruent to itself. Yay, reflexive property. So we're going to fill this in. Then triangle ABC, from A to B to C, that means I got to start over here and name this one C to D to A. If a pair of corresponding sides are congruent by the reflexive property, AC would be congruent to AC. So these two triangles are congruent to each other by angle, angle, side. So as we go through all of these things, we're just picking out 3 parts of every triangle to match up with 3 parts of another triangle. And as soon as we've got it, then poof, all the parts of the triangle become congruent. Oh, look at that, a 2-column proof that uses angle, angle, side. So we planned it out here. Now we get to actually write it out. Look at the diagram. Look at what they told you here. This is what you're given, so the diagram should already have that stuff on it. Eventually we'll start with blank diagrams, or you have to write your own. And we get to just duplicate all of that stuff right there in the first line every time. So the reason for the first line is given. Now, what's a statement that we can make that will sound like the reason for it would be, if lines are parallel, then alternate interior angles are congruent. Again, we are writing out the proof that we planned in the previous step. So here, this should be alternate interior angles are congruent. Well, what were the alternate interior angles that we were talking about? Oh, they were BAC and DCA. Angle DCA. There we go. Now, AC congruent to AC. I think most of you have conquered this. You know it is the reflexive property. And it's okay if you just write reflexive. I don't need the whole word property. Okay, so now if we've got this set of angles and this set of angles and this side in that order, angle, angle, side, then I've got 2 congruent triangles. And that would be because of angle, angle, side. Last page. Write the proof. Well, hey, we're going to do 2-column proof, and we're trying to sort of analyze this ahead of time to know what we're looking for. I need to prove that these 2 triangles are congruent. All right, well, I've got 4 things that I could do. Is it going to be SSS? Is it going to be SAS? Is it going to be ASA? Or is it going to be AAS? These are the only 4 triangle congruence theorems that you've got. Yes, we will go to right triangles and we'll cut it down to actually just 2 letters, but these are the 3-letter versions for triangles that are not right triangles. So looking at this diagram, what do you think we could do? Well, hey, they already start us off with an angle and a side. So right there, you know what? Let's not try to bother with side, side, side. Let's use one with the angle, shall we? And, ooh, do you see what I see? I see some vertical angles right there. So just by looking at this diagram, I know these triangles are going to be congruent because I got vertical angles here. I get a side matching up with another side, and I got my third thing, my angle over here. So this proof is going to have to end up as an angle side angle as my final reason. So here we go. Statements. And these are pretty short. Yes, they'll get longer. Statements. Reasons. Number 1, N, M congruent to N, P, and angle M congruent to angle P. Why? Why can I say that? Because they said it to me. It's given. Great. It was nice to start off that easy. So the next thing I need to say is something about this other angle that I decided has to be congruent. So that will be, I'll call it MNL. Angle MNL is congruent to what other angle? Well, if I start at the M here, let me start at the P here. So I'm going to call this other angle PNO. Congruent to angle PNO. Why can I say that? Because they're vertical angles. There it is again. When in doubt, vertical angles, I think could be a good rule for this section. So now, I have established an angle, a side, and an angle match up with an angle, a side, and an angle from the other triangle. So that means I've got my 3 parts. There it is. Angle, side, and angle. So now I get to write the prove statement. I'm proving it right here. NML congruent. Oh, they named it this way. NML. So we need to name ours NPO. Triangle NPO. Why can we say that the 2 triangles are congruent? Because of ASA. And now the flow proof. Well, here we go. This is the statement. This is the reason box. So you're going to see statements and reasons sort of split up and come back together, all to make a final statement with a final reason. And look at how tiny that reason box is. I bet it's just got room for 3 letters, huh? Okay, here we go. RP bisects SRQ. RP bisects SRQ. Well, hey, that makes RP an angle bisector, and therefore I have 2 congruent angles. This one here and this one here. So again, RP was the angle bisector of this big angle. Clean that up. Why can I say that? Oh, it's given right there. Got it. Then I've got angle SRP is congruent to angle, well, it must be QRP. Whoops, angle QRP. And why are those 2 angles congruent? And this is a little weird, I grant you. It's not given. The reason that these 2 angles are congruent is because of the definition of angle bisector. Tricky. But if you have a card for it, it can be a reason. So, next, we're showing angle S congruent to angle Q. Why is that? Because they told me so. It's given. That was easy. And then I've got segment RP. Let me clean this up again. Segment RP. Congruent to segment RP. Reflexive. So now what do I have? I've got an angle, and a side congruent to an angle, and a side. So now I can write my triangle congruent statement. The 2 triangles S, R, P, And triangle QRP are congruent because of AAS. Angle, angle, side. So as you point to each thing on the paper, you say what it is. I got an angle, I got an angle, I got a side. That helps you decide which of these 4 triangle congruent statements you've got. Last one. Recall example 4. How could you prove ABC congruent to CDA using ASA? Whoa. Okay, let's take a look back at example 4. It was this one. And we had the parallel lines, and we had an angle opposite at the other corner from another angle. So let's go back and see what the question was again. We've got, let me duplicate that drawing. So we've got something like this. That was a little sketchy. Sorry. Artistic license. So we've got a trapezoid here, A, B, C, D. And now they wanted us to prove how could we have done it with triangle ABC congruent to triangle CDA using ASA. Well, didn't we already do this? Yeah, but we used angle, angle, side the first time we did it. We said this angle, and this side matched up with this angle, and that side. So they're asking, how can we undo this and instead make it an angle side angle thing? Well, if we're given this angle, and they want us to use angle side angle, what else could we do here? Here's the key. We knew that with this transversal cutting through the 2 parallel lines, I've got a congruent angle here and a congruent angle here. You know what? Let me make those 2 arc marks. Hey, guess what? One of the very first theorems you have a note card for in this chapter says that if 2 angles of one triangle are congruent to 2 angles of the other triangle, then the third angles are congruent. Hey, that kind of makes sense, because if I knew that these 2 added up to, say, well, 120 degrees, then these 2, okay, well, they're congruent, so they have to add up to 120 degrees. That only leaves me one number for this third angle. So my third angle, these guys are going to have to be congruent too. So now, where am I? This means I didn't even need the givens. I just needed to say I've got my alternate interior angles and AC congruent to AC, and last my you kind of want to call them alternate interior, but that's really not what we need to do here. So we've got an angle, a side, and an angle matching up with an angle, a side, and an angle. So how can we write that in here? It will look like this. There you go. I've saved the time and filled it in for you. You can pause the video to get all this. But we started off with the given, so that gave me one set of angles. Then we said the alternate interiors are congruent. That gave me another set of angles. Then we said, hey, you know what? If we got 2 that are congruent, then the third one has to be congruent. So that gave me this third set of angles, and so I've used that number of arc marks. Now, these guys, not this one, but this one, angle, angle, and now I have a side. But here's the key. Here's the really big important thing here. Just because I got the statement about an angle followed by a statement about an angle and then a statement about a side, just because I did the proof in this order does not mean that my proof is AAS. It's actually ASA, because what matters is where these angles are located. These angles that I'm talking about happen to be at either end of this side. So the order that they show up in the proof is not important. Maybe I really should have stuck this side comment up here in between so that the order of the proof, what statement I make and what reason, actually follows the congruent statement. That's okay, we could have done that. But what I'm highlighting to you is where these angles are actually located in space on this diagram. That's the important thing, to know what letters you're going to use for your triangle congruent statement. So I have an angle with the 2 arc marks, the side, and then the angle with the 3 arc marks. So looking at the diagram, I did angle, side, angle, congruent to angle, side, angle. And so that means I can make this last statement. The entire triangle is congruent to the entire other triangle by ASA. Okay, long video, sorry. Thanks for tuning in.